It's fine. Actually, I was struggling with my connection.
Oh, okay, no problem.
Okay. So what were we doing last time?
We were doing, we did, I guess I was going over it. So I was doing factorial for myself, or the n factorial plus 2. We had reached APGP, API.
Okay. Did we do fractions?
No, no. We,
Okay.
we did like 7/5, and then you did the question about quotient remainder. That those the other.
What's the last question we did?
No, I would have to just go back and see the it's in my notebook. 1 second. Oh, this one, yes. Is this 0.0012 minus the 12 point
Okay.
something bar?
Yes. So, and we didn't do anything after that.
No, I don't think so. That seems like the last question in mine.
Okay. Perfect. Okay. So, let's start. So that is basically the end of number properties.
Okay.
So we have to start with algebra today then. Okay, so what do you understand by algebra? Where do we use?
I mean, we usually like translating word problems into variables.
Correct. So wherever we have to find some value that is unknown, that is where we have to use algebra.
Mhm.
Okay, the use of variables is algebra. And before we start algebra, let's go over a few terms that we use very frequently.
Mhm.
Expression, equation, and formula. What is the difference between these?
Um, I know equation is like an x plus y is equal to 5, for example. That's in quadratic equations or equations. I don't know what expression exactly means.
Okay, so expression is something which is a standalone value, which you don't equate it to anything.
Okay.
For example, this if you have to write a quadratic expression, it can be ax square plus bx plus c. Now we can put any value of x in this, and we will get a corresponding value for the expression. So expression can return different values based on the input value.
Okay.
This can be variable or it can be a simple constant, maybe 99. This is basically a single term, but this can also be used in place of an expression.
Mm.
When we say equation is something which wherever we have to basically equate the expression to some constant value or maybe zero,
Okay.
or when two expressions can also be equated. So wherever you see equal to sign, that is where we say it is an equation. And this is the difference between expression and equation. Now when we come to formula, what is your understanding of the formula?
Formula is used to solve something. It's kind of like you put in the input the values and then you have an equation in it.
Yes, correct. Very good. Now, formula is something, maybe we can say that a plus b whole square will return a square plus b square plus 2ab. This is a formula. Formula is more like a universal truth. We can say distance is equal to speed times time. That is another formula.
Mm-hmm.
So this will always hold true.
Yep.
When we compare this with equation is, for example, we have an equation 2x minus 3 is equal to 7. If we have to solve this equation, we can take 3 on the other side. We will say 2x is equal to
Yeah,
10
it's
or
equal
x is equal to 5.
to
Now, formula is a universal truth. It is true for every value, but equation is true only for specific values.
yeah.
For example, this equation 2x minus 3 is equal to 7 is true only for x is equal to 5. For any other value of x, this will not be true.
Mm-hmm.
Okay. Now, what do you understand by fraction?
It's like maybe like part over whole.
Part over whole, yes, that will also represent a fraction.
One where
Anything that can be written in the form of p by q, where
yeah,
q is not equal to 0 and 1 is a fraction. The moment we put q is equal to 1, this becomes an integer value.
yes.
So p by q represents a fraction. This can be part over whole, this can be whole over part, anything. So numerator can be greater than denominator or numerator can be less than denominator.
Yes.
Both will represent a fraction. This is proper fraction, this will be improper fraction. Okay. Now the kind of questions that are asked on GMAT. For example, let's say we have to compare 9 by 19, 5 by 11, 15 by 31, 3 by 7, 10 by 21. The task is to arrange these values in an ascending order. How will you do that?
I mean, the long method is to find the LCM because then you make the denominators the same. Then you'll be able to.
Very good.
But I'm sure there's a shorter
So,
method.
yes. Now, you correctly pointed out that that will be a long method in this case. Why? Because the method that you are suggesting is generally used when we have two values to
Yeah.
compare. If there are more number of values, then uh, we cannot use LCM because that will until or unless we are given the same denominator, and that will not be the case. So LCM will be a very long way to solve this. So in these kind of problems, whenever we are given proper fraction, that means numerator is less than denominator. And all of these are more or less similar in the sense that the numerator is less than half of the value.
Mm.
We can get a numerator which is greater than half. So what do we have to do? We take reciprocals in this.
Okay.
That means we can do 19 over 9, 11 over 5, 31 over 15, 3 by 7. Sorry, this will be 7
7.
by 3, and 21 over 10. Now, the values which are lower, which are smaller initially, will be greater now because we have taken reciprocals. Now, you will always find a general sequence, a pattern associated in these terms. Here, the pattern is numerator is twice of denominator plus 1. So we
Yeah.
can write this as 18 plus 1 over 9, 10 plus 1 over 5,
Mm-hmm.
30 plus 1 over 15, 6 plus 1 over 3, and 20 plus 1 over 10.
Yeah.
So basically, what do we have? We have 2 plus 1 over 9, 2 plus 1 over 5, 2 plus 1 over 15, 2 plus 1 over 3, and 2 plus 1 over 10. Now, this 2 will not make a difference. We are just adding 2 to all the terms here.
Yeah. So just you compare 1 by 9, 1 by 5.
Yes. So we basically have to compare 1 by 9, 1 by 5, 1 by 15, 1 by 3, and 1 by 10.
Mm-hmm.
And that we can easily do.
But
Greater
they
the
should be
denominator, lower
reciprocal.
the value. Yes, right. So now, the greater the denominator, the lower the lower the value. This is the lowest one.
Yeah.
This is 2. This
So
is 3, 4, and 5. But we have taken reciprocals.
mm,
So we have to take reciprocals again. Or we don't even need to do that. So whatever is smallest here will be the greatest in the actual fraction given. So which one is the, if we have to write now, 5 is corresponding to 1 by 3. So this is the greatest. 1 by 3 is the greatest here. So this will be the smallest in the actual fraction. Fourth, then
mm,
third. This is
second.
second in the reciprocal. So it will be fourth here, and the smallest in the reciprocals will be the greatest value.
Okay. Okay.
This makes sense?
Yes. So first you inverted them, then you saw the pattern, and then you rearranged them, and then okay.
Take reciprocal. If it is a proper fraction, then we can take reciprocal. Then we have to identify pattern.
Yeah.
Once the pattern is identified, you can figure out whatever we can add or subtract, and then we can figure out which is the lowest or the greatest value.
Okay.
And if we have taken reciprocal, then the actual fraction will follow the exact reverse order.
Mm.
This makes sense?
Yes.
Now, okay, there is a question. Question number 90, I think, of data sufficiency. Yeah. You can try this one, and we will discuss this question.
Question 90.
Yes.
Okay. Is it E?
Yes, that is good. And how?
I because I got T1 is equal to D2 plus 30 over R2 plus 30.
Hmm.
So the value, like the value still stays the same. Like in the sense, how do you compare D2 by R2 with D2 plus 30 by R2 plus 30?
Correct. Very good. Okay. So in this, let's say we have a number line like this. So this is 0. This is 1. Now D2 by R2 can be here, or D2 by R2 can be here.
Hmm.
1 is generally considered as the normal value. Now, if we are adding, so the question here is D2 plus 30 divided by R2 plus 30 greater than D2 by R2, right?
Hmm.
Now let's take the value, a fraction which lie between 0 and 1. For example, 3 by 5, D2 by R2. When we add a positive constant value, maybe 5 here in both the cases, what do we get? We get
8 by
3
10.
plus 5 over 5 plus 5, which is 8 by 10, which is
Yeah.
0.8. The original value was 0.6.
Yeah.
We see that the value is increasing, right?
Yeah.
by adding a positive constant value, by adding the same positive constant value to both numerator as well as denominator, the value of the fraction moves towards 1. That is, it increases. Now let's check the other case. When it is, the fraction is, so this is a case for proper fraction. The next case is for improper fraction.
Yeah.
That is the fraction which is greater than 1.
So like 5/3 you can take.
Yes. Let's say 7 by 5.
Okay.
If we are adding a positive constant value to both numerator and denominator, we see the value increases, the value becomes 12 by 10, which is equal to 1.2. And the original value was 1.4.
1.4. Yeah.
Here, by adding, we see a decrease. And here we saw an increase. So when we are adding the same positive constant value to a fraction that is greater than 1, we see that the fraction moves towards 1.
Yeah.
That is, it starts to decrease. Therefore, until or unless we are given where does d2 by r2 lie, between 0 and 1
Or more than one.
or greater than 1, correct. If this information is given to us, then we can answer the question.
Yes.
Before that, we cannot answer the question. Adding the same positive constant value to both numerator as well as denominator, we see a shift towards 1.
Yeah.
Whether the original fraction is on the left of 1 or on the right of 1. And if we are adding a negative constant value, the same negative constant value to both numerator as well as denominator, then the fraction moves away from 1. Adding a positive constant value, the fraction moves towards 1.
Okay.
Adding a
Fraction
negative constant value, the fraction moves away from
away
1.
from one.
Yes. You can maybe note this down.
Yeah, yeah, I just noted it down.
Yeah, perfect. Okay. How will you do question number 116?
So we know that half of the, well, 3/4 of 2/3 of the total number of guests were managers. So the
Correct.
question then becomes, non-managers will be also half by X.
Non-managers. Non-managers, total non-managers, correct.
Yeah, so then obviously statement one, if you know X as X basically is total number of
Mhm.
no.
Because this, what your x by 2 you are saying, that is the total number of non-managers. So
Uh,
that includes guests as well as uh, the employees who are not managers.
okay, 2/3 of the passengers were company employees, which means 2/3 of X are company employees and 1/3 of X are guests. Then
Correct.
3/4 of the company employees were managers.
So how do
Oh,
you
oh, okay, sorry, 1/4. That means 1/4 were non-managers, right?
one fourth were non-managers for
Yeah,
company employee?
yeah.
Yes, correct.
Okay, so 1/4 were non-managers. So then why can't we do it 2/3 of X plus 1/3 X is equal to 690? Shouldn't it? Hmm.
2/3 of x plus x by 3.
Yeah.
Yes, that is true. You can get the value of x.
Yeah, if you get the value of X, won't you be able to solve it?
Yeah, so you need to identify uh, what fraction in terms of x will represent company employees passengers who were not managers.
So 1/4 of um 2/3 of X.
Hmm. And that will be,
X by 6.
yes, correct.
Okay, and the second statement says that there were 230 passengers who were guests of the company employees. So X by 3 is equal to 230.
Yes, correct. 2x by 3. No, x by 3,
X by
correct.
3, yeah.
Yeah,
Okay.
yes, correct. So x by 3 is 230. So x by 6 will become 115.
Yeah. The point is to identify how to rewrite the statement of company employee passengers who are not managers.
So how are you actually writing this? Just trying to rephrase what is written, or are you creating any diagram or
No, I'm
table?
doing this, I'm doing like employees is equal to two, like let total number of passengers,
Okay,
employees is
okay,
equal to
okay.
2 by 3x, guests is equal to 1 by 3x. Then I read that if 3/4 of the company were managers, I realized, oh, so that means 1/4 will be non-managers.
Yeah, that is correct. Okay, perfect. How will you do question number 131?
We have to basically show that how can we get the value on the first truck? It has to be greater than half of the value of all six shipments.
Correct. So basically, we have to figure out if the total shipment, total value is 100, then greater than 50 is on truck one.
Yeah, yeah, and then determine if S3 is will be able to fit on that truck or not.
Yes.
So S3 and S4. Again, I would try and first like make all the fractions in the form where the denominator is the same. Um, this is how I would do it, to then compare the values and see, knowing S2 and S4 were on the first truck.
Yeah. The whole idea is, let's say this is T1 and this is T2. We are given that S2 and S4 are on the first truck. S2 represents 1 by 5th of the value, and S4 represents 3 by 20 of the value.
Yeah,
That means 1 by 5 plus 3 by 20 is on the truck 1.
yeah.
Or we can say 1 by 5 is 4 by 20, so 7 by 20 is already on the truck. Now, is S3 on the truck?
Um,
Okay, agent
well,
earning, fraction.
well, we don't know. Or do we? Let's see. Basics.
X. This table shows the value shipment of fraction total value.
The problem is, how do you compare that 1 by 6? Wouldn't you need to take the LCM for the whole, first all of them, and then
Now, if we put 1 by 6 here, then +21
yeah, plus
plus
10,
10.
31 by 60, which is greater than half. Yes.
So I'm just trying to figure out, like, okay. And S1 and S6 were shipped on the second truck. The point is, we can put any shipment in place of S3.
And the value will be greater than half. Is that what you're saying?
Now I'm trying to figure out, where are we given that we have to load 3 shipments each. We are not given that.
With each shipment, 6 shipments were shipped from a factory on 2 trucks, with each shipment entirely on one of the trucks. Each shipment, you're right, it isn't
We are not given that 3 shipments have to be on one truck.
one
So
truck.
I'm just trying to figure out, I can put an S3 here on truck 1, but
Yeah.
I can also put S5 as well. I can put S6 as well. How will that help? And if I take statement 2, S1 and S6 were shipped on the second truck. S1 is 1 by 4, S6 is 1 by 10, 20 is the LCM, 5 plus 2, 7 by 20 is on
Second truck.
second truck.
But as soon as you can't put S3 on the second truck, because as soon as you put it, the value will become greater than half, and then that can't be possible.
Yes. So statement 2 will answer the question.
Yeah.
because this is a piece of information that is given. So this has to hold true. The shipments on the first truck had a value greater than 1 by 2.
Yeah.
So both are giving 7 by 20, but that is the reason why we cannot put S3 on truck 2
Yes.
by using
Second
second
one.
statement.
Yes.
Yeah, correct. Now there, okay, a standard question type. Okay, this is data sufficiency. Yeah, question number 194. This is one of the standard question types in GMAT.
Oh, okay.
Most most often a question like this is asked.
So it'll just be 1 minus 1 by 5 plus 1 by 4 plus 1 by 2 is equal to 10.
Yes, correct. That is true.
I mean, I can
Or
do
you
it.
can say maybe x by 10, x minus
Yeah.
the.
1, yeah, x minus all the sum of these three will
Yes,
give x,
correct.
and then we solve for x.
That will give the answer.
Yeah.
Correct. And how about 195?
Hmm. So the second one should increase, right? Because the value of x is actually no, the second one should decrease. 1 minus, let me just think about this. If the value of x is going up, the fraction is getting smaller. 1 minus a smaller fraction will give you. So if 1 minus 1 by x will decrease, right?
No.
It will increase. Okay.
Okay, so one way of doing this is like you are trying. So if we are using in the second scenario, x will be the greater number. If the value of denominator increases, the overall value of the fraction decreases.
Yeah.
And we are subtracting a reduced value.
Oh, so that means it'll be a bigger number.
Yes. So that is one way of doing it. But then what is the purpose of mentioning 165 to 166 here? The idea is to solve it in the best possible manner.
Yeah, no, absolutely.
So why they have used 165 and 166, and should you use this information or not?
I guess you should. I mean, what does why one?
Yes, you should use this information. That is correct.
Yeah.
And in what manner you will use this information?
Well, I noticed that the third one is essentially 1 by x into 1 over x minus 1.
Correct.
So that's, I guess it's because they're I mean consecutive integers. There must be some. I don't know actually why they've taken those two numbers.
Yeah. So they have given the various options on the statements as in terms of x basically. And how is x increasing? They are using integer values. From
Yeah.
lower value to higher value, they are changing. So whenever you have to use such an information, never try to use actual what
Values.
numbers are given to you.
Okay.
Try to use values which will be a lot easier to
Like
calculate.
C increases as X increases to
Maybe
C.
2 and 3.
Yeah.
So for 2 and for 3, what is the value? If we put 2 in statement 1, 4 minus 5 will give negative 1.
Yes.
3 in 1 will give plus 1.
One.
Yes,
Yeah.
there is an increase. 1 minus 1 by 2 is 1 by 2.
Yeah. 1/2.
1 minus 1 by 3 is 2 by 3. Yes, there is an increase. 1 minus, 1 upon 4 minus 2 is 1 by 2. And 1 upon 9 minus 3 is 1 by 6. Now there is a decrease.
Yeah.
So 1 and 2.
Okay. Okay. Take easier and smaller values and then apply.
Yes, but use the values which align with the information given. If it is X is increasing, so we have to use the values which are increasing. And using the values in such a way, for example, why I'm using 1 by 2 and 1 by 3, or X is 2 and 3, not 1 and 2, because the moment I choose 1 in statement 3, I will get 1 over 1 minus 1, which is 1 over
Yeah.
0, which
Which
makes
is
it
not
not defined.
defined. Yeah.
So I have to ignore 1 here. So
Hmm.
I have to use values which will make sense, which will not make the expression not defined.
Okay. I understand.
Okay. Okay, this is again a very interesting problem. I guess you might have done. So there is a question in Manhattan also like this, 2 to 6.
Hmm. I mean, I would draw it out.
Yeah, actually that is the easiest way. I have actually seen the explanation in Manhattan, so that is not actually worth it. So and how will you draw
Um.
between 0 and 1?
Straight. Yeah. 1/4 and 1/3. So obviously 1/3 is greater than 1/4.
When you have to draw, there are two ways. One is you can use a number line from 0 to 1, or you can use a number line from 0 to 100.
Okay.
You have to mark in fourths and thirds. So using fraction as 1/4, 1/3, 1/2, it is sometimes a lot difficult. But when you have to, when you are 0 to 100, 1/4 is 25, 50, 75,
Yeah.
33 and 66. That actually is a lot easier. We know this is one length, this is 25, this is 8 point something, and this is close to 17. This again is close to 17, this is close to 8, and this is close to 25. So we have three different lengths. We have to find the value of 1/25, 1/8, and 1 upon 16.66. This is what we have to do.
Okay.
So not 1 by, sorry, not this, but we have to find 25/100, 8/100, 8.33, whatever it is,
Okay.
and 17 upon 100.
Okay.
This is actually a lot easier to calculate, like 1 by 4, 8 into something, 8 into 12 is 96. So it is 12 times something. So 1 by 12, 1 by 4 is only in option D.
Okay. 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 This is so you've done it on 0 to 100.
0 to 100 is actually a lot easier to calculate.
Hmm.
Your mind is very much adapted towards natural numbers, integer values.
Yeah.
Now, this is probably an easier question. If they give you instead of thirds and fourths, if they give like sevenths and 11th, then it will be a lot difficult.
But can you explain to me how did you get that 8, 17? Like, so you did
Yeah.
one, actually you did 1/3, 2/3, and 3/3, na?
Yeah. So basically, it is when we have a number line 0 to 100.
Hmm.
So what does 1/4 means? 25%?
Yeah, that's, yeah, 1/4 is 25, 2/4 is 50, and then
And
75 is 0.
75.
Yeah.
1/3 is 33.
33,
1 by 3,
60, yeah.
66. 2 by 3.
Acha, you've done the difference. That
Yeah.
you
Basically
can
100 by 3. I'm one
yeah.
third means 100 by
No,
3.
no, no. I just realized वो 8 कहाँ से आया? वो 25 and 33
Yeah. Correct. So this is 16 2 by 3. This is 8 1 by 3.
yeah.
And this is 25. So now we can find 25 by 100.
Yeah, 8.
So that essentially rules out option E, because 1 by 4 is not there.
Yeah.
Then 8 1 by 3 is 12 into 8 is 96. So it has to be 1 by 12. Now, which of the options do not have 1 by 12? So first
Yeah.
three do not have. So you have your answer.
Okay.
Does this make sense?
Yeah.
Okay. Okay. Now let's. What do you understand by degree of an equation?
Mm, I don't know. Degree.
Okay. Degree of an equation is the highest exponent of a variable in any term of an equation.
Oh, you mean like ax square plus bx plus c. So x square in a, that's the,
So this means degree 2.
yeah,
Ax plus b,
1.
degree 1. Correct. Ax cube plus bx square plus cx plus d,
3.
that means it. Perfect. Make sense?
Yes.
Now, how will degree help? What information we can get from the degree of an equation?
Well, depending on the value of x, it can be.
So x is a variable, so you do not have any value of x.
Oh, okay.
For example, x square minus 5x plus 6 is equal to 0. What can you get from the degree of an equation?
I don't know. I mean, I know it's used to solve that equation, but
Okay. And maybe another equation like 2x minus 3 is equal to 7.
yeah,
Can you try and solve both these equations?
sure. X is equal to 3 or 3 comma 2,
Very good.
and x is equal to 5.
Very good. So why are you getting, how many values of x you are getting?
Ah, 2.
When the degree is 2, you are getting 2 values of x.
Okay.
Number of possible solutions is represented or is given by the degree of the equation. If degree is 3, you will get 3 possible solutions.
Okay.
If degree is 2, you will get 2 possible solutions. The number of solutions is represented by the degree. Now, solutions may be distinct or may not be distinct. For example, if we are given x square minus 4x plus 4 equals to 0,
2 in both.
yes, correct. We will get x minus 2 whole square, which means x is equal to 2 and x is equal to 2. So although we are getting the same value, but still there are two distinct factors, x minus 2 times x minus 2.
Yeah.
That is why we are getting two values, but both the values are same. So degree actually gives you the number of solutions, and it is also that we may or may not get the number of solutions represented by the degree, but we certainly cannot get more number of solutions.
Okay.
The number of solutions will always be less than or equal to
Equal.
uh, degree, right?
Yes.
Okay. Now, let's say we have, so what is a linear equation?
Um, like is 2x plus 5 equal to 7 a linear equation?
Yes, very good. Linear equation is degree 1 equation.
Okay, yeah. And quadratic is degree 2.
Yes, perfect. Now, 2x minus 3 is equal to 7. You
Mm-hmm.
just found the answer as x is equal to 5.
Yeah.
So you get only one, since the degree is 1, the
Mm-hmm.
only possible solution is 1.
1.
Now, 2x plus 3y is equal to 8. How many solutions?
Well, I mean, it depends on the value of x and y. Degree is still 1.
Hmm. Degree is still 1, correct?
Hmm.
But you are
Oh,
right. The number of solutions will depend on the value of x and y.
yeah. I mean, you can put x as 0 and then give a value, and then put y as 0, give a value, but then x can be 1, then y will have a.
Correct. So that means infinite solutions.
Yeah.
Now, this means why? Because we have two different variables. And in order to solve an equation having two different variables, we need two equations to solve these.
Yeah.
So number of variables is equal to the number of equations. Then we can solve these equations completely. Now, if I add along with 2x plus 3y equals to 8, we add another value, another equation, 4x plus y equals to 6. Now, what is the value of x and y?
Now you can just let's see. Let's should we multiply the second one by one sec. 4x plus y is equal to 6. 2x plus 3y is equal to 8.
So how do you solve the equations when we are given two
Oh, so
equations?
you have to. I was trying to see if I can like get rid of one variable. So
Okay.
if you subtract them, then you get minus 2x um, m- plus see, plus 2y is equal to 2.
Hmm. So, okay. So let's take these two values and sorry, shall I clear the screen once?
Yeah, yeah. X minus y is equal to minus 1. I'm getting.
So 2x plus 3y equals to 8 and 4x plus y equals to 6. Now, when we have two variables and two equations,
You know
what
what?
we can do is,
Actually, if
yeah,
you just take the first one and you multiply it by 2, you get 4x plus 6y is equal to 16. And the next equation is 4x plus y is equal to 6. Now subtract the 2. Then x goes missing, so you get 5, y is equal to 10, y is equal to 2. Then put y is equal to 2 into any of the equations involved.
okay. Now, okay, that is one way. So there are basically two ways in which we can solve any a pair of linear equations, and this solution is known as like solving the equations simultaneously. So we have to consider both the equations together. First is by method of elimination. That is what you are trying now.
Yes.
Elimination is when we have to eliminate one variable. So, and what is the process? You have to equate the variables, the coefficients first. So if I multiply equation 1 by 2,
Yeah.
the variable will be same. 4x plus 6y is equal to 16 and 4x plus y is equal to 6. I can subtract and I will get rid of x.
Yeah.
So, I will get 5y is equal to 10, which will give y is equal to 2.
Mm-hmm.
Or what I can do is I can multiply equation 2 by 3.
Okay, yeah. Either way, you'll get rid of y in the scope.
Yes. So we have to get rid of a variable.
12x
Because if
plus
one variable, yes, very good.
12x plus 3y is equal to 18.
18.
Yeah.
Yes. So now we can subtract maybe equation 1 from equation 2. So
Yeah.
we have to flip the signs. So then we get 10x. This gets cancelled is equal to 10.
Then x
We
is
get
equal
x
to
is
1.
equal to 1. And when you get the value of one variable, we
You
can
can,
put that value
yeah.
back into any of the equations.
So,
And we will get the value of the other variable.
mm-hmm.
Okay. So this is the method of elimination. Now, second is by method of substitution. In substitution,
Oh,
we
okay.
have to substitute the value of a variable from one equation into other equation.
Yeah, like 4x is
Now, for
equal to,
example, from
yeah.
hmm,
4x
correct,
is
correct,
equal to 6 minus y, x is equal to 6 minus y by 4, and then put that 6 minus y by 4 into 2 times that plus 3y is equal to 8.
very good. Or we should always try basically to minimize the effort
Yeah,
required.
so,
Now here,
yeah,
instead of using x, we should
y.
have used y,
So y is equal
because
to 6
y will
minus
simply
4x.
be 6 minus
Yeah.
4x. And we can put this value straight away in the first equation, right?
Yep.
Okay, very good. Now let's try. So 2x plus 3y is equal to 8, and 6x plus 9y is equal to 20. Now solve for x and y.
So by elimination, it doesn't work,
Okay,
right? Because you're getting 6x plus 9y is equal to 24.
correct.
And then the second equation is, so if you,
Yes, you're right. Then what should we do?
I guess, try substitution.
Okay,
10, 20, 9y is equal to 20. So, well, substitution doesn't work either. You're getting 24
okay,
20.
yes. Now the reason is it doesn't matter which method we use,
Yeah.
we should always get the same value.
Yeah, but
If one
shouldn't
way is not,
a
yeah.
6x plus 9y is equal to 24?
Hmm. So
I'm just saying
what
that
do you?
I
Hmm?
understand that 2x plus 3y is equal to 8.
Hmm.
But like the second equation, is it correct?
Yes, equation can never be wrong,
Oh, okay.
incorrect.
Fine.
So okay, now let's try to understand what does a linear equation in two variable means.
Okay.
If I have to write this equation, let's say first equation 2x plus 3y, I can say 3y is equal to negative 2x plus 8,
Yeah.
or y is equal to negative 2 by 3x
Plus 8 by
plus
3.
8 by
Yes.
what does this mean?
That for.
Can you correlate this with this?
Yes.
So a linear equation in two variables is actually it represents a straight line.
Yeah.
Now when I plot the first equation, I get this, and when I plot the second equation, I get this. 2x plus 3y is equal to 8, and 6x plus 9y is equal to 20. Now this is so what it actually is, it is, so uh, if the equations are in this form, a1x plus b1y is equal to c1, and a2x plus b2y is equal to c2, then so if a1 upon a2 is equal to b1 upon b2
Yeah.
is not equal to c1 upon c2,
Yes.
then the above setup,
Are they parallel lines set up?
yes, very good, represents,
A pair of parallel lines.
yes, a pair of parallel lines, and parallel lines never meet in space.
Okay, so 2 by 6 is equal to 3 by 9.
Correct.
Ratios of the coefficients of x and y are equal, but C1 and C2 are not in the same ratio.
Correct.
Mm.
Parallel lines never meet in space. Hence, so the question was solve for x and y. Hence, no solution.
Yes.
Or we can say no real solution.
Mm.
Make sense?
Yes. I have to learn this. I haven't
Okay.
seen these.
Then, okay.
Mm.
But this is a very frequent question type on GMAT.
Okay, fine.
Because GMAT will never ask you 2x plus 3y equal to 8 and 4x plus y equal to 6. That is like everyone can do that question. The GMAT never asks such a question.
Mm-hmm.
So these are all the special scenarios. GMAT always prefers to ask special scenarios. So whenever A1 upon A2 is equal to B1 upon B2 is not equal to C1 upon C2, then this represents a pair of parallel lines. Right?
Yeah.
Okay. So uh, what does not represent a pair of parallel lines? Or when we wrote these two equations, 2x plus 3y equals to 8 and 4x plus y equals to 6, why were we able to get an answer? Or actually, what does that answer represent?
Intersecting lines. Mm.
Yes, you are right, intersecting lines. One line is
Because it's for
this,
one particular pair of
and the
vectors.
second line is this.
Yeah.
Now, when we solve this, we get x is equal to 1 and y is equal to 2. So 1 comma 2 is actually the point of intersection.
Yeah.
So a solution of a pair of lines, we call it a simultaneous solution. Simultaneous means this point is present on both the lines. This point will satisfy the equation of this line as well as this line.
Yes.
So, and that is why we say this is the point of intersection.
Mm.
Make sense?
Yeah, it's a point of intersection. That makes sense.
Okay. Okay. Now let's try to solve this equation.
Oh, but in this, A1 by A2 is equal to B1 by B2 is equal to C1 by C2.
Yes, correct. Now, what should we do?
Mm. So this just if you. But it's the same with one solution. It's one line. There are not equations. It's only one equation.
So we are given actually two equations.
Yeah, but it's just the ratio is different.
Yeah, that is correct. And so
I've seen in
here,
some questions on the GMAT, they'll give you two variations of the same equation, and then in data sufficiency ask you to. Yeah.
so what does these two equations mean? Here A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2.
Hmm.
This actually means this and this.
Oh, okay, so it's one line.
This represents a pair of parallel lines. Sorry, a pair of overlapping lines. If A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2, then it represents a pair of overlapping lines.
Represents a pair of overlapping lines. Yes.
But they will not ask what does this represent. So what is the question is always solve for x and y.
Okay, so yes, I understand. They expect you to know that if you notice that the ratio of all three are the same, then that represents a pair of overlapping lines.
Yes. So what is the answer to the question solve for x and y?
Isn't it infinite solutions?
Very good. So wherever the two lines meet, that is a solution.
Yeah.
Now they meet at every possible point. This is a solution, this is a solution, this is a solution. So we can mark the answer depending on how the answer choices are framed. Either infinite solutions or more than one solution. Both are correct.
Okay. Oh yeah, yes.
Because a pair of lines can generally give three possibilities. They are parallel, no solution. They are intersecting lines, one solution. Or They are overlapping lines. Then more than one solution or infinite number of solutions.
Makes
Right?
sense.
Okay, perfect.
So basically, you're doing coordinate within the topic of algebra.
No, coordinate is a lot different than this. So it is just a touch base touch basing with the coordinate
Okay,
geometry,
okay.
because a line is a simple linear equation in two variables. Now
Yeah,
linear equations,
that's
when
the
we do,
definition of a line. So yeah.
yeah, so when we do linear equations, basically we are doing equations of a line.
Hmm.
But when we do coordinate geometry, we have to figure out in how many ways we can frame an equation based on what is given to us.
Okay.
So this is just equation is with us, more than one equation is given, we just have to find the point of intersection.
Hmm.
That is linear equations, that's it. Okay, now let's say we are given that cost of 2 pizza, 3 burger and 5 coke is, let's say, $1.50, and the cost of five, not five, let's increase the number, 6 pizza, 10 burger and maybe 15 coke is $1.52. Now you have to find two things. Find the cost of 4 pizza and 10 coke and 8 pizza and 8 coke.
So I can find 4p plus 10c in terms of like it's basically 100 minus 6b.
But that is not the value.
Okay, so it has to
We need to
be
figure out a value.
a
Yes.
value. Fine.
And for both the questions, there is an option cannot be determined.
Okay, okay.
So you need to basically figure out as well whether you can actually find the answer or not.
Or not. Yeah. Eight. Yeah, how I don't know how to do this. Hmm.
Okay. So let's write in terms of equations. So 2p plus 3b plus
Plus
5c
30,
is equal to 50,
50, yeah.
and 6p
Yeah.
plus 10b plus 15c is equal to 152. Now if I multiply equation 1 by 3, then I get 6p
So that means you can
plus
find
9b.
P plus C.
No.
No.
So
Oh, you get the value of B.
yeah.
Yeah, and then that, yeah, once you have the value of B, then you can find, then I already have 4P plus 10C is equal to 100 minus 6 now. I mean, 6 into 2, so yeah. Okay. We
So
did that.
since b is equal to 2, we can find in the
4P
first equation 2p plus 6 plus 5c is
multiplied by,
equal to 50.
yeah,
Yeah. So 2p plus 5c
5
is
is equal
44.
to 44
So
and
multiplying by 2,
4P
we
plus,
get.
yeah.
Now that means first part is done.
Yeah.
Okay. What about the second part?
Second part, let's see. 2P plus, mm, 6P plus. How do you do the second part?
Hmm. Now the point is
Uh,
we have two equations and we have three variables. Now we are fortunate to figure out this value. We cannot find the values uniquely since we have three variables and two equations. So 8p and 8c we cannot find.
hmm.
So cannot be determined is the answer for this one, and for this one it is 88.
Okay.
Now the point is, when can we find the values and when we cannot find the values?
Okay.
Now, whenever, so in this, the equations are basically a1x plus b1y plus c1z is equal to d1, and a2x plus b2y
Okay. Now there are three
plus
variables.
c2z is equal to d2. Now, if out of 3, two of the ratios,
Are equal. Are they?
yes, two of the ratios are equal, then we can find value of the third variable and value of the same two variables in the same given ratio.
Value of the same two in the same. Acha, so that's why you found it in two
As in the,
choices.
yes, as in the equations given. We are given in the equation
Yeah.
here 2 pizza and 5 coke, and here 6 pizza and 15 coke. So a direct multiple of 2.5. Here also a direct multiple of 2.5. Pizza is to coke is given in the ratio
2:5.
5. Yeah, so 5 for every 2 pizzas we are ordering 5 coke, right?
Yeah.
So when this scenario is given, then we can find the value of the third variable, because here which ratios are same? A1 over A2, B1 over B2, and C1 over C2. If out of these three, any two are same, then we can find the value of the third variable and
We can
the
find the
value of the
value of the
other.
third variable and the same, the ones that are equal in the same given ratio as in the equation itself.
Yes, correct. And in the same ratio, it can be uh, 2p plus 5c, it can be 4p plus 10c, it
Yeah.
can be 100p plus 250c, anything, but in the same ratio.
Mm.
Okay. Okay. Now this is a standard question type, like question number 55.
The above table, what is the number of green marbles in jar X, acha. Z. So question is, what is Z?
Correct.
Z is equal to question mark, X plus Z is equal to 160 in R, in Q, Y plus Z is equal to 120, and in P, X plus Y is equal to 80.
Hmm.
D?
B for boy or D for Delhi?
Delhi.
Yeah, that is correct. Now, how did you do this?
So I took from equation from jar P and did y is equal to 80 minus x. Put that value into equation from Q and found the value I got a new equation saying z minus x is equal to 40. Then z minus x is equal to 40, and if you add z plus x is equal to 160, you get z is equal to 100.
Okay. So, okay, fine. what we can do is we can do a few more questions on this type, because this is where this question type represents where we are asked to find a specific expression. So uh, usually we are given expressions to figure out. Here the equations are given in such a way that they could have asked for expressions, but they asked for the individual value. Now if we add all the equations here, we will get
2 times
2
x
times
raised
x
to
plus y
power.
plus z,
Yeah,
and this will be equal to 120 into 3, that is 360.
yeah.
So dividing by 2, we get x plus y plus
50
z
is
equals
180.
to 180, and then you can subtract this x plus y is equal to 80. So
Yeah,
we will get z is equal to 100.
yeah.
So this is
The
we can
best
do a
one.
few more questions like this,
Yeah.
but and the way GMAT wants us to solve, you can solve pretty much every single problem on this, but the
It's
way
the
it is
most
supposed to be
efficient.
solved,
Yeah.
that saves significant amount of time.
Hmm.
So we have to maybe do some little more practice in that direction.
Yeah, I think that's the same.
Yeah, because I figured out pretty much your concepts are good, so you don't have a problem with the concepts. It's more about how you should execute.
Yeah, I think that's the, I mean, like, I'm wondering if, like, for the homework or, like, the topic wise breakdown that you have, if I should do those questions and maybe just either send them to you, because I'm getting, at least for algebra. Because the thing is, like, my mind, I'm trained to immediately, when I don't have time, I'll first try substitution
Hmm.
instead of
Now,
saying,
I would say neither elimination nor substitution. GMAT, now these are standard things. GMAT never asks questions which are very straightforward. It involves some twists and turns, and there is always a smarter way of doing things. So we have to figure out, like, so what you can do is, uh, whichever way you are solving, so you can maybe took some pics of that, WhatsApp me, or maybe create a PDF,
yeah, or
send me.
I can scan it and send it.
Yeah, yeah, which whatever works for
Yeah.
you, that is fine. But I think our focus should be more towards the execution side, because concept wise you are doing good.
Yeah, it's about, like, how do I take the least, like, what is the strategy I should use in a question, and how do I get better at using that as my first strategy than using the longer method?
Correct.
Yeah. Um,
So
okay.
we need to do a little more work on that. And do you have the question bank of Manhattan?
Question Bank of Manhattan. How, I don't think so. How did that count? What does that look like?
So on the Manhattan website, probably did you enroll only for the test series?
No, yeah, like, in the sense, are you talking about? Yeah, yeah. The question bank is that, topic-wise questions, nah? That's what you're saying.
Yeah, yeah,
Yeah, yeah, I
yeah.
have that.
So maybe try as many questions from algebra from there as well.
Yeah. So I'll tell you what I'll do. I'll try that right now, and I'll do the ones from yours, and then I'll try and scan it in the next 2 days.
Yeah,
At least, so then you don't have to do all, you don't have to look at all of them, but, like, if maybe we can pick up 4 or 5 questions and then
yeah.
go.
Wherever we see a scope of improvement, we can do
Yeah,
that.
I think that's and then is are you okay with doing class on Wednesday morning?
Wednesday morning is fine. Yes,
Yeah,
that
same
is okay.
time.
Yeah, yeah,
Um,
same time.
if possible, 6:15 is a little better, because then I can run to work on time. Um, if that's okay.
Yeah, that's fine. So yeah, perfect. We can start at 6:15. That is not a problem. Actually, I today also we could have started at 6:15. I just figured out that my Wi-Fi was not working, so
Yeah,
actually
that's
started
no,
with
I
mobile
understand.
data.
No problem. And then the half an hour we can just adjust for whenever. I'm sure we can figure it out.
Yeah, that we can do.
And then if you could also connect me, um,
Yeah, I actually forgot, and I'll send an email maybe today or tomorrow.
okay, done. Yeah, that would be. I'd like to get started with my
Yeah,
verbals.
sure.
Okay, good. So now I'll get the algebra stuff to you before the next class.
Sure.
Okay.
Perfect.
Thank you so much.
Okay.
Okay.
Yeah.
Bye.
Okay. Bye bye. Have a good day.
You too.